How to learn Russian to master Russian. Lesson 3. How does our brain work while learning? Всем привет! Здравствуйте! Как дела? Hi everybody! How are you? I am teacher Vladimir and How to learn Russian to master Russian introductory course. In this lesson, we will get familiar with short and long-term memory mechanisms and learn how our brain works while learning. In the last lesson, we learned that to do something successfully, we should follow the laws of nature. Our body and our brain are parts of the nature, and they have certain abilities and limitations set not by humans, but by the nature. Those limitations become obvious when we speak about short and long-term memory mechanisms. If you have a look at this picture, you will get a very clear imagination of how short-term memory works. It is really like a leaky basket. Russian people say about that. В одно ухо влетело, в другое вылетело. It went into one ear and went out of the other one. Neuroscientists, or scientists who try to find out how our brain works, have proven that short-term memory works through electrochemical changes in our brain. Electrochemical changes are not stable and they are dissolved as soon as learning intervention stops. At that, even during a learning intervention, the information disappears from short-term memory in the same way as water goes out of a leaky basket. That is why one should repeat anything many times to keep the part of information in short-term memory. The mechanisms of long-term memory are more complicated than those of short-term one. There are many elements that you can see in this chart are involved. However, this chart doesn't show what happens with our brain while learning. I will try to explain it in easy and understandable terms. The same as the water from a leaky basket can go into a tank only if it becomes overfilled, the information from short-term memory can be transferred to long-term memory only if a learner puts a serious effort in learning and do it for a long time. Perhaps the word transferred is incorrect. The key term here is neuroplasticity, that is the ability of our brain to change its physical structure while learning. As I have explained above, short-term memory works through electrochemical changes that dissolve as soon as a learning intervention stops. If a learning intervention is intense enough and long enough, a physical structure of our brain changes. New neurons and new connections between neurons grow. And this new physical structure can keep information for a long time or even forever. It can be compared to recording information on a hard disk in a computer. A magnet head changes hard disk magnetic qualities, and this new disk magnetic structure can keep information for a long time in the same way as our brain keeps information imprinted in new physical structure of our brain. However, Russian people say, лучше один раз увидеть, чем 100 раз услышать. That means it is better to see one time than to hear 100 times. That is why I want to show you a video fragment in which Lara Boyd, an English neuroscientist, speaks about how our brain works while learning.
The key to each of these changes is neuroplasticity. So what does it look like? So your brain can change in 3 very basic ways to support learning. And the first is chemical. So your brain actually functions by transferring chemical signals between brain cells, what we call neurons, and these trigger a series of actions and reactions. So to support learning, your brain can increase the amount or the concentrations of these chemical signaling that's taking place between neurons. Now, because this kind of change can happen very rapidly, this supports short-term memory, or the short-term improvement in the performance of a motor skill. The second way that the brain can change to support learning is by altering its structure. So during learning, the brain can change the connections between neurons. Now here, the physical structure of the brain is actually changing, so this takes a bit more time. These types of changes are related to long-term memory, the long-term improvement in a motor skill. Now, these processes, they interact, and let me give you an example of how. So we've all tried to learn a new motor skill, maybe playing the piano, maybe learning to juggle. You've had the experience of getting better and better within a single session of practice and thinking, I've got it. And then maybe you've returned the next day and all those improvements from the day before, they're lost. What happened? Well, in the short term, your brain was able to increase the chemical signaling between your neurons. But for some reason, those changes did not induce the structural change that are necessary to support long-term memory. Remember that long-term memories take time, and what you see in the short term does not reflect learning. It's these physical changes that are now going to support long-term memories and chemical changes that support short-term memories. Structural changes also can lead to integrated networks of brain regions that function together to support learning. And they can also lead to certain brain regions that are important for very specific behaviors to change their structure or to enlarge.
Now, after learning of how short and long-term memory work and watching the video that proves the fact that real learning needs time and efforts enough for changing brain physical structure, you will not have any doubts that it is impossible to learn something easily and quickly. Bye for now, good luck and all the best. See you at the next lesson. Пока, всего вам доброго и удачи, увидимся на следующем уроке.